The Spectra CX Simulink importer takes a Simulink model as input and creates SCA components and an SCA application in a Spectra CX SCA model. What I'd like to demonstrate today is how to go about importing this into Spectra CX, as well as taking the behavior of this Simulink model and bringing that into the components behavior. So here I have a Simulink model, and it's a simple model that takes a binary source and sends data out in two different directions. So it sends data through these components, this bit to int, this modulator, demodulator, into bit, and to this bit error rate calculator. The binary source also sends data directly to the bit error rate calculator. The results are compared, and hopefully everything will be equal. There will be no errors. So the results are displayed in this display here. So the first thing I want to do is I want to validate this model in Simulink to make sure that what I've modeled is correct. So I run the model, and as you can see, there are no errors. These are the bits that are being sent, and everything looks good. So once I make sure the Simulink model is valid, the next thing I want to do is generate source code for these subsystems in Simulink. So embedded encoder allows me to generate the behavior for these blocks as C or C++ files. I'd like to take that later, that generated code, and use it as the behavior for my SCA component. So I'll show you how to do that shortly. In Spectra CX, I'd like to take that model, that Simulink model now, and import it into Spectra CX using the Simulink importer. So here I have an empty Spectra CX model with 3 elements that I've added that you'll see are used during the import. So here I have something called a build configuration, which is used in code generation. And I have 2 dependencies, a dependency on the Linux OS and the x86 processor. So what I want to do is select the model and select the Simulink model. So the SCA model and the Simulink model. And I say import. Select the Simulink import wizard. And here we have a dialog with several different selections. The first thing I want to do is I want to select my Simulink model file. Then I want to select the subsystems that I want to bring into the model. So in this case, I want to bring all the subsystems in except for the display. So remember, the display was the thing that displayed the bit error rate and the errors. Well, in my case, I'm just going to output that to standard out, so I don't need that one. I'm going to input it into this model, and I'm going to select those dependencies that I created earlier that I mentioned, as well as the build configuration. So when I bring the subsystems into my SCA model, these dependencies are going to be set up for me, and this build configuration is going to be assigned to all my implementations. I also have the option of generating the application diagram as well as the component diagrams, and whether or not I want to create a controller. So in this case, I want to create a controller, and I'm going to give it name controller. So all my results came in under a folder called SCA import results, and you can see that I have components for each one of my subsystems that I selected in the importer dialog, as well as I have an application, and I have some IDL that was generated for me based on the types of data that were sent in and out of the ports in my Simulink model. So if we look at the modulator here, if I look at its diagram, here's my modulator component. It implements the resource interface, and it's got 2 ports. It's got an in port called data in of type double, and it's got an out port called data out, which is complex double. I've got an implementation, and it has a build configuration assigned to it, as well as 2 dependencies. So at this time, I should be able to validate this model with regards to the SCA, and it should be valid. And everything's valid. So what I have now is I have an SCA model. However, it doesn't do very much. There's no behavior for these components other than the default SCA behavior. I also have an application here. And as you can see, I have this controller, and I have all my subsystems that are connected together properly with the correct ports and connections. I also, because I specified a controller, I also have resource connections to each subsystem. So if I start my controller, all the other subsystems get the start message, for example. So what I've done in advance is I've taken this information and I've put it in another model and cleaned it up a little bit so it looks nicer. So here I have a model. It's the same model, but I've moved components around, straightened out the connections, and so on. So it looks a little more like the Simulink model that you saw earlier. So here I have my binary source, and I'm sending data directly to the bit error rate calculator, and I also am sending data through these components here to the bit error rate calculator. The next step is I need to integrate the code that I generated into Spectra CX. So if I look here, I've got my source code for, let's look at the modulator for instance, and I've got my source code for the modulator. So in here there's a method called step. So the idea is I want to initialize the modulator, and every time I want to process some data, I step the model, and then I look at the data. Okay, so if I look at the source code for my modulator, I've already generated the source code for my components, and if I look at the modulator, and I'll just look when what happens when I receive a message. Okay, so here in my modulator, I receive a message on my data import called push real data, and it's a double sequence. So the first thing I do is I take the information that's been sent to me and I put it in the Simulink, the modulator input buffer. I step the model, which takes that data and modulates it and puts the result in the output buffer. And then I take the results that are in the output buffer and I put it into a sequence that I'm going to send on out to another component out of port. So that's basically all I really do here. And I've gone ahead and I've compiled everything in advance. So I have all my components ready to run. So they're all here. And if I look at for the modulator, I've got a binary here called QPSK modulator. So all my components, I've taken the behavior from each one of those Simulink generated source code blocks, and I've put them into Spectra CX for SCA components. I've compiled everything compiles. So the next thing I'd like to do is run everything. So I copy all my binaries and everything to a location, and I'm going to run this platform. So using the PrismTech Orb and Core framework, I'm going to open this monitor and show you the platform. So here I have this node, and it's got 3 processors. It's got an input processor, an output processor, and a control processor. And what I want to do is I want to install my application that I've created. So I've generated source code from Spectra CX, and I've generated the descriptors from Spectra CX. And I'll create the application, and I'll just give it a name. So now my application is created, and I want to start the application. So now I've started the application, and as you can see, the data is being sent directly and indirectly, as we saw in the application here. So data is being sent directly to the bit array calculator, and it's being sent indirectly to the bit array calculator. The data is being compared, and there are no errors. So what I've done is I've taken the behavior from Simulink and I've put it in each one of these components, and I've displayed it here. So just to summarize, the Spectra CX Simulink importer takes the structure of the Simulink model and imports it into Spectra CX. So what I get is a Spectra CX model with components for each subsystem and an application. And all the subsystems are connected as they were in the Simulink model. I generated source code from embedded coder, and I took that source code and I implemented the behavior for each one of those blocks in a Spectra CX SCA component. And then I generated the source code for those components, compiled it, and I generated the descriptors for those components and the application, and I ran it on a platform and verified that the behavior was the same in my SCA model as it was in the Simulink model.